Welcome back. In this series of videos, we'll be taking a look at solutions to problems to help you get ready for the midterm exam. Posted in the reference folder, you can find the document for midterm exam review. And what we'll do is we'll shoot a video for each of the individual units one by one and help you get ready for that particular exam. So with no further ado, let's get started. Okay, I'm hoping that you can see this. What I have on the document camera, new toy here, is solution setups, and I will also post these solutions to Moodle so you can reference those. Problem number one is just a straight out example of an equation for us to solve. So we're going to start with the distributive property. Make sure that you don't lose the 3 times -3 on the back end of that distributive. And the rest is pretty straightforward. We're going to add 9 to both sides. We'll isolate our variable term, and then we'll divide by 3 to solve for x. And with not a whole lot of muss and fuss, it looks like we got a good solution for problem number 1 at x equals 12. Slide this up so you can get a look at problem 2. Problem 2 is your basic proportion to solve. So we'll cross multiply, and that'll get started. On the one diagonal, that's going to get us 4 times x. On the other diagonal, it's going to get us 26 times 50. And that's where the 1300 came from, according to my trusty calculator. Another divide by 4, and we've got a solution at x equals 325, and we are off to the races. Okay? Problem number 3, we get our first word problem involving t-shirts and shorts. So if you read the problem, it does tell us that there are a total of 250 items sold. I chose to let x represent the number of t-shirts being sold, and that leaves 250 minus x to represent the number of shorts that are being sold. The dollar value is the basis for our equation. We realize that each t-shirt brings in $2. So that's the 2 times x, $2 for each t-shirt sold. In addition to that, we'll make $6 for each set of shorts that we sell. So you'll see the 6 times the quantity, 250 minus x, and the total of that money is $600. Solution involves a distributive property on the 6 times the quantity. 6 times 250 is how the 1500 got there. 6 times negative x on the back edge for negative 6x. Combining like terms, we're going to get negative 4x, and I took the liberty of going right ahead and moving the 1500 to the right side of that equation by subtracting 1500, and that's how the negative 900 got there. One more divide, and you and I have solutions for x at least. So if we divide both sides by negative 4, we will find x to be 225. The problem asked for how many of each particular item. So you now know how many t-shirts were sold. That's the 225. To get the number of shorts, you guessed it, it's 250 minus that 225. And that leaves us 25 pairs of shorts being sold for that particular problem. So it's not a whole lot of tough stuff. Again, the total 250 got us a way to represent the number of shorts as the total minus the number we had already allotted for t-shirts sales. Problem 4 coming at you. Problem references chocolate chip cookies and sugar, and it tells us that 4 batches of chocolate chip cookies require 5.5 cups of sugar. So that's my left side fraction. The question then says, suppose you decide that you would like to make 10 batches of cookies, and how many cups of sugar would you need? So just be careful. If you're putting batches on top, make sure you have batches on top of both fractions, and cups of sugar then are in the bottom of both fractions. Again, to cross multiply this thing, we're going to do, I should say to solve, we'll cross multiply. One diagonal will get us 4x. The other diagonal gets us 5.5 times 10. And so 4x is 55. And a quick divide by 4 gets us to 13.75. So for us to make the 10 batches of cookies would require 13.75 cups of sugar. And that takes us through problem number 4. We have one more problem to look at as it relates to Unit 1's review. So I'm going to switch out those solutions and bring in a solution set that would let us take a look at number 5. Here it comes. That's a beautiful shot of my desk. All right. Here's problem number 5. The biggest problem you have as you begin this is to decide which of the letter grades best serves the representation of x. So you read it critically, and what I think we want to do is get to the bottom of that relationship stack. Which letter grade seems to be based on which other letter grade? And in reading, it looked to me like most of the letter grades somehow were related back to how many D's there were assigned in the class that semester. So I chose to let X represent the number of D's, figuring that then verbally it's easier for me to translate the numbers of other grades based on that. So my recommendation to you, even though there's no such thing as a wrong place to put X, I do believe there is a best place to put X, and I do believe it's for the number of D's. So reading the problem, we realized that there were 5 more C's than D's, so that puts C's in at X plus 5. We know that there were 4 times as many B's as there were D's, and that makes B's be represented at 4X. Be careful on A's. The reference point for A's is B's, not D's. And it does say in the problem that there were 2 times as many A's as B's. So 2 times 4X got us 8X to represent the number of A's. To write your equation, I'm going to slide it a little bit so you can see it. We're simply totaling up the number of each letter grade. So 8X is A's, 4X is B's, X plus 5 is C's, and X is D's. Might have been handy if I would have grouped those with parentheses just to make it a little easier for your eyeballs. Total number of grades assigned, 75 for the semester. Combining like terms, if you add 8, 4, 1, and 1, you'll get 14X. The only constant term on the left side is the plus 5. So we'll let it sit for a moment. Now let's move it. So we're going to subtract 5. So that'll make us 14X sitting on left and 70 sitting on right. A clean divide gets us to X equals 5. Remember, as in most problems, you don't just need to know X, you need to know about other things in addition. So the problem asks us how many of each letter grade were assigned that semester. So X references D's, so we now know that there were in fact 5 D's. And if you go back to your initial variable representations, C's was X plus 5, so it made it 10 C's. B's was 4 times 5, that's 20 B's. And A's was 8 times that 5, and that would be 40 A's. And that is a final solution for problem number 5. And that, my friends, is the last of the Unit 1 problems. So I'll be back soon with a video that takes us through the review problems for Unit 2. We'll see you then.